Welcome to our talk today, and thanks for joining it. Thanks for attending. We will present today our experiences with the end-to-end machine learning pipeline. We have practical experiences from BSH, what we had. We also developed over the last years a 3D architecture overview. We were developing it together since more than 6 years, started at Telefonica and then reached out with machine learning processes, frameworks, and until we reached now to this architecture. Maybe some short introduction to us. I'm René Brunner and professor at the Macromedia University, head of study programs, digital technologies and coding, and also have a company, Datamix, who's doing consulting services. One of our customers is BSH. And I would hand over to you, Joachim.
Thanks. And I'm Eric. I'm a strategic advisor and lead architect for AI and data platforms, or the overarching topic AI and data. So this also includes strategic topics going beyond pure technology, topics like change management, expert career paths. So how does he have to reinvent themselves to be attractive and be prepared to efficiently and effectively apply AI, which, for example, means a good data foundation. And we brought you, as René already mentioned, our main topics today is our MLOps platform that evolved over several years. But before we go into the questions, why do we even need MLOps? We first want to give you a short introduction. What was the motivation? So who is BSH and why did they need it? And I think the clicker doesn't really work reliable. We have to do it manually. Yeah. So we are, I think, one of the largest manufacturers for home appliances in Europe. I think place 2. We create all the appliances that you can find in a kitchen and or even outside, so like laundry care, but in the kitchen, inside kitchen, you have cooling, dish care, surface cooking and ventilation. We have also small appliances, and maybe we just switch then can I, yeah. And under our belt, we have several well-known brands like Bosch, Siemens, Neff, and Gaggenau, but also from other countries. For example, Greece is Pitsos constructor. You might have heard also. We have an ecosystem brand which is called Home Connect because we want to make the kitchen smarter. Therefore, we have an underlying base layer to transport the event data of all these appliances to be able to build more intelligent applications on top of that. That's essentially just a transport layer. And on top of that, we have then some derived scenarios like kitchen stories where we combine the knowledge which appliances you have at home and which taste the household has over time with some approach, with giving, for example, recipe recommendations. This is where AI comes into play in these more complex scenarios. And this was essentially the main reason why we thought, okay, if you want to roll out many machine learning models into production, we need some automatism to have the complete overview and reproducibility whenever something non-intended happens, and also being able to adapt fast. And therefore, we created this MLOps platform. But before we go into DevOps, into MLOps, we first want to show the difference by answering the question, what is DevOps and why is it omnipresent in software engineering? And who of you knows about DevOps? Oh, I would have expected even more. Therefore, we want to go back in time a couple of decades when we still had just traditional software development without machine learning. And over the years, a common pattern evolved how to do software development in an automized and secure and efficient fashion and how to work together as a team. And this is how this DevOps paradigm essentially evolved. First stage is continuous integration. So you have something like a versioning system so that teams can work together. You always know which version is in production, on which version your team is working internally to prepare it for the next iteration. So you won't have this scenario that I observed several times in companies where someone goes on holiday and then you have, after a couple of days, the rest of the team were running around like headless chicken. Where's the latest version of the software? And sometimes it's on the laptop of this person who went on holiday, and that's what you want to avoid here. So it's really about teamwork, but it's also about reproducibility. So for the project manager, just to know what is currently in production and what is being prepared for the next iteration of a product or increment of a product. So then the next thing is more about something like a quality gateway. So you do automated testing. This is the continuous deployment. You create some tests where you say if the software doesn't pass these minimum boundaries, you don't want to deploy it as the next version of the code. Essentially, answering the question, does it work as intended? That's the reason for this stage. And last, then you deploy it, you run it, and if during running a software, of course, you want to monitor it to check if the performance metrics that you might have defined with your customer are met. For example, minimum or maximum answer times for a website. Also, yeah, these are robustness metrics. Also checking if the underlying infrastructure is working as intended, having early warning systems if you have to replace some parts of the infrastructure before it breaks down. Now, the question is, what is MLOps? And according to our understanding, it's just an extension of DevOps. So the process is essentially the same. You have the same stages. But now, instead of only one artifact, you have 3 artifacts. You still have the version code because every machine learning and AI project still needs some code around it. But now you also have a model that you have trained. So ideally, this model should also have a version because you want to compare if you maybe keep the code the same and just deploy a new model that should make better performances. And ideally, you also have a version data snapshot. And this is relevant for the reproducibility because compared to traditional debugging, if you want to debug the performance of a model, you ideally want to have the data that it has been trained on to check maybe there's some anomaly in the data that you have overseen, and therefore in a special edge case, your model does not perform as intended. Then again, you have the test stage, and here you just have additional tests. You not only want to test your code if it works, maybe with the business logic, if it works as intended, but you also want to see if the model is behaving as intended. So it's essentially the same as you do with code. So does it, for some edge cases that you already know, does it give the expected predictions on these well-known data points? Or you can also compare it to another model that is already in production. Is it at least performing as well as the other model? And then last stage is again very similar. In addition to the traditional monitoring, you now have model monitoring that you are probably all aware of, checking things about the degradation of a model like concept drift or data drift. So the result is you have a much faster rollout into production. So from a project management perspective, that's faster time to market if you roll out a product, or time to value if it's a service. The customers can much faster benefit from that. And also you have this complete reproducibility along the whole pipeline, that you know what you're doing, and you always have complete transparency what your team is currently working on and what is in production. Now the next question is, with all these frameworks out there, why did we even bother to build our own generic MLOps pipeline? Because we could have just bought one of these many platforms out there. And the reason is multifold, partially it's because of the specific situation in our company, because we have to deal with many and heterogeneous use cases. So we have slow and fast moving data, we have images and natural language processing. Also, we have traditional sensor data, partially from the IoT data. So what the events that our appliances produce that we want to use to understand the usage of the appliances, but also to check how we can, for example, predict failure, by using all the sensors that are inside these appliances. We use this for transparency, but we also have our Industry 4.0 data. Our corporation has over 40 factories worldwide, and in order to optimize the production and doing, for example, predictive maintenance, we also get a lot of sensor data there, which is again a different scenario. So what we needed was a generic platform to tackle all these hundreds of use cases throughout the corporation without having to buy many different platforms and having a large operational overhead. Therefore, the goal was clear. We needed something flexible, versatile, and also modular so that it could evolve over time when new use cases come in that have new requirements. The other thing was how to handle the complexity. When I started 7 years ago, we had many code versions on some lost Jupyter notebooks. So the typical POC stage that data scientists like to leave, and then hoping that some engineer will pick it up and bring it into production. We had hundreds of functional users with thousands of roles, because you can imagine each of these machine learning projects, they need some connection to some database, and we have hundreds, if not thousands, of different databases where you need to get your data or store the data of the predictions. And in addition to that, data science has a high employee fluctuation. So if we don't automate some of these processes, either you have to manually document a lot of processes, or the knowledge is just going away with the employee. So we evaluated several ready-made platforms already also in our previous project before that at O2 Telefonica. Yes, you can buy something off the shelf. Some are even open source. But the problem is you have this black box effect. They have built something, and you don't know when, and more often than not, after having this fast success in the beginning, sooner or later you stand in front of a massive brick wall because maybe the platform was not extensible, or in addition to that, often it's that the vendor is telling you, yeah, we have this on our roadmap in 2 years, you can have this, but you need it maybe in 3 months. So we thought about how can we break this up into different modules that at least we are able to do these extensions on our own when we need them. So for example, we combined MLflow with Aporia, where we bought Aporia as just a module that is then a black box, but it's just responsible for model monitoring. Therefore, it's not that crucial if we have to replace it later. And so we benefit from both strengths. We have still the ability to have fast changes, but we don't have to build everything from scratch. Essentially, most of the time, we use these modules mixed between open source and modules we have to buy because there is no appropriate open source project there. And then we glue them together with some code that we write. I think now it's your part, so I hand over.
Oh. Yes. Yep. All right. Then let's move on with the pipeline at BSH. So we brought all together what we had before, and then we built this 5 layers. We will deep dive in there. We have governance, infrastructure quality, MLAI, and Gen AI. And we said, okay, it's one layer, but we thought we cannot reach it. And that's why we meant even steps in there, like ingest, pre-processing, training, deploying, serve, run, and monitor. And then in each one, we have this flexible components. We can plug in, we can remove it. We are independent. We don't have this mentioned black box. And next steps, we go in these areas step by step. First, the governance. Nobody likes it, so everybody wants to train the cool models, do something cool. But it's really important. Why is governance important? Who of you would like to work in such an office? Probably nobody. No, we need a clean office, then you can concentrate, you can really work and be productive. And this is really the foundation layer that we're using. So we have in the governance is also security. We don't put it a separated layer. We say it's part of the data governance. Very important that it's not hacked, that you don't give user content which users cannot see. We have the data protection, especially in Gen AI. We will also go later. Of course, it's an important topic right now. That data protection, we see a lot of Gen AI tools, RAG system. Everybody can do it. Like you go to YouTube, you have a tutorial, you have your own RAG. But then if you want conference data, you need also the, you still need then the user management that you can only see the pages you're allowed to see. Even if you go then there's agentic frameworks in the future, you think then each agent should know what he can provide. It's still noisy, no? It's off. Yes. Now it's better. I lost the cable. All right. Then the data protection, also user management, who can see which data. We have a data catalog that also you don't know which data is in your company. You want to create a chatbot or whatever, or a cool machine learning model, and you need really a catalog who can access it, who is data owner. Has somebody else used it? Who can tell me about the content of the data? Who can ensure that the quality is there? So we have here a data catalog. There are different tools out there. At the first, we bought some tool, but later now we developed it by ourselves. That is fine granular. Still. Now it's working. The doctor is coming. We had some sound issues, but now it's better. Perfect. Then we have also talks about before Gen AI, data lake, data mesh, how to organize the structure. It just disappeared, Gen AI. Nobody's talking about data mesh anymore, so I also will keep it short, but it's also a topic how to organize your data. Then we go to the next layer. If you have organized all the data privacy and everything, we say, okay, you need the infrastructure. And why is it important? Imagine you are on this road, it's really nice, you can walk, you can make some tests, for example. But if you have a real infrastructure performance, then you can really drive faster and bring your models fast. So it's really time to market. You can reduce it if you have a complete MLOps pipeline, which is performant, and you can roll it in several days out your new models. And also to keep on track, update your models and everything. And for this infrastructure, we have also different components. For example, the data ingestion at the first time. We have streaming ingestion, batch ingestion, streaming, Kafka, Flink, and different technologies over there. Also, we have to say in this project we have AWS, so we have some AWS components we're using there. Storage S3, for example. We have the compression. If some models are deployed in devices, you don't have a lot of space, you don't have a lot of memory, CPU, so you can also use model compression. And this is also for agents. If you think in the future, maybe agents will be in devices using there, then also you need to compress your data, your models, because it's really limited storage. Anonymization, pseudonymization is always staying topic, so you can get the data, but it really needs to anonymize, it needs to pseudonymize. You cannot get customer data that you don't have the contact data. So we have also some keys, frameworks over there, existing ones, and we have pseudonymize different keys. So we also set up our own pseudonymizer library. And also the monitoring, if data is not incoming, also the classical. So it can be that nobody knows for weeks, no data is coming, and then some business dashboard is failing, there's no data, and you lost the data because in Kafka it's not there. So you also need the monitoring that data is incoming and it's stable, and to supervise it. Afterwards, you have the preparation, feature engineering, transformations of your data, labeling. We have Voxel 51 for image labeling. We had Labelbox, Label Studio for different labeling cases, also for text labeling. This is also the, let's say, the world before Gen AI. Now labeling is not so important anymore. We will show it later that you probably anyhow need it, but this is the classical ML approach you need it. We have Spark for large data pre-processing. You need it for all types. If you want to extract data, if you want to transform it, we're using here Spark and Spark streaming. For example, Kafka, Spark streaming with the pre-processing and then storing it on the data lake. Also data enrichment, the quality of the data. If you have you're missing data, you can impute them, for example. And you can also use Gen AI for this data enrichment. It's really for machine learning and labeling, it's really important that you have lots of data, that you have good quality of data. And if you enrich this data from the internet with test data, then it's even a better quality. We have then training models. It's going for GPU clusters mainly, but we also have older models, let's say non-deep learning models on CPU. Of course, these are cheaper, and then we prefer to go with lower costs in the training. Cost is a main driver in the GPU cluster. Afterwards, we have tools for test and deployment. Like you say, it's MLOps, it's derived from DevOps, and we use the classical DevOps tools. We had Bamboo. Now we have GitHub Actions, which is more integrated. It's less tools and it's much more comfortable. Code versioning is important, what Eric mentioned already. We have a lot of containerization, like infrastructure, that we say data scientists just put everything what you have in a Docker container. We ship it. So they don't need to worry about deployment, AWS configurations, cloud, everything. They get a container, they get a boilerplate, and then, okay, use it, we ship it, and we make all the infrastructure handling. And then run and serve, we need then the infrastructure on this level, monitoring if there are failures on the servers. We have alerting, then informations are sent to Slack channels, to emails, so we notified if anything goes wrong. Yeah, and below we have these libs tools. We have own dev libraries, GitHub repos, which is shared in the company. Then they can use it, like anonymization. We had connectors and so on. You have a workplace also if you want to start. At the very, very beginning, like 6 years ago, there were no workspaces. There were older laptops where you cannot do anything. 8 GB RAM, I think 7 years ago, where data scientists need to develop. And now we have a workplace dedicated with all freedom where they can install all the tools in the cloud, which is also then separated, everything pre-installed. What is important for data scientists to speed up the process. And we have job orchestration. Also, if you want to monitor, if you have a lot of single jobs laying around or cron jobs, and then somebody shutting down machine, suddenly something breaks. Maybe also some people experience this. We try to avoid this with the job orchestration tool, Apache Airflow. So we have everything scheduled there. We see the errors. We have also the error messages consolidated to one place. All right, that's the infrastructure now. The technician is done, and now the quality is going back. Yes, jetzt. Was? Oh, okay, now I don't move so much. Then we have the GIGO principle. Who knows what the GIGO principle is? Oh, not so many, only 2. It's very important. For example, it means garbage in. Then you put it to any tool or any system, you can say. And what will you get? Of course, you get, again, garbage, because it's not magic AI, it's just what you put in, it's what it brings out. Maybe also in ChatGPT, it's reproducing the content which is in the internet and then putting it out. So maybe if your answers are wrong, maybe it's also the content which is put to the system. And this is true for classical ML algorithms, and it's also for Gen AI, of course. And therefore, we have then the next layer in our architecture, quality. What is important is schema validation, that the schema is correct which is incoming. Deduplication is often caused, it's maybe not so much impacting the quality. Sometimes, yes, if you make group bys or counting, then also deduplication could be problematic because you get more events, and it happens quite often. Also, Kafka don't have a guarantee that there are no duplicated events are sent. You have to filter it out later. Then you can use like Hoodie or Iceberg, different tools on S3 which are managing this and have libraries for deduplication. Then also single field plausibility, you should do this. It just means that you check the field, that there are no null values, or if you have a temperature sensor, it cannot be negative, then it's an error. There are different tools to manage this. We're using Glue, for example, for the streaming, and there are also data quality. You can make easily these checks. And also multi-field relational plausibility. This means if you have temperature sensor and another sensor, that one sensor cannot be maybe 1000 a temperature and one maybe 100 Fahrenheit, so there's something which is implausible. These are the data ingestion, you can make this, and then afterwards you have this preparation and statistical tests or ML, pattern plausibility, and there you can still work with classical machine learning. Even if you want the Gen AI, where everybody's talking about, if the data quality is not so good, the Gen AI model is not so good. Or if the more data points you have, the better it will be. So you could also do a classification algorithm and feed then the Gen AI also with a classification algorithm. And then there you need, again, the labeling, which we have shown before. So the better the data is prepared and tested, of course, the better the quality of the data you're putting in. Then we have the training, also data versioning. We have MLflow, so you know all the models that have been trained, with which data they have been trained before. There might be also a law from the EU that you need to justify why which model is doing what, and then you have all tracked versioned. And you can also jump back to previous versions if you see one is not so good anymore. Explainability of the models, why did what, you have all the parameters of the models over there. Testing, deployment, also prod and staging, often also, like seen now a lot, everybody, or some people just deploying a rack and say, okay, here's the rack, and they don't have even a staging system. Nobody thought about this, but yes, you need a staging system, you can make the tests, and once these tests are fine, then you roll it out in prod. This will also increase your the quality of your system. We have code checks. Also, there's, for example, SonarQube, which is checking for security issues, also for quality issues as well. And afterwards, once the model is run, then we have data drift detection. We have Aporia for model monitoring for the classical machine learning models. And it sees, for example, a classical case was Corona, then online behavior of people shopping changed from several days. And then you have a data drift, and this needs to be detected. Okay, people not buying this anymore, they're buying a different product. And we have this detection. We're getting a message, for example, for Slack. If you have done this training, it's automatically started, and we can then deploy the new model once data changed. All right, data quality. Then we're going to the next layer, let's say classical ML and AI. Why is this important? Well, this is one example. From BSH, if you're checking the fridge, there could be some questions. Can I still eat this avocado? Is it good? What should I cook tonight? Like recipes. I need to remember to get milk. You see, it's old. Maybe you forget. You don't have the milk, or it's old. You cannot drink it anymore. And these could be use cases like expire date, reminder, your avocado is expiring. Please buy a new one or cook it before it's wasted. You can get recipes based on stock, which is in the recommendation engine, classical ones. or never run out, or remind you to purchase the new groceries, that you don't run out of milk, for example. These are classical use cases. Also, there are new use cases with Gen AI, of course, that you can talk with washing machines or your home devices and chat with these. Okay, then let's say the classical ML layer. There you need this labeling, as mentioned, Voxel 51, Label Studio are tools. And we also have these tools flexible. So if you see one tool doesn't fit anymore, or they're slower in development, or also some cloud vendors, they have the appropriate tools. And then we see, oh, at some point they don't have this feature, like Joachim mentioned at the beginning, and we need this feature because it's some specific use cases, then we can say, okay, no, we don't need you. We plug in another open source tool, or we plug in another vendor. So it takes some time to squeeze out one tool and another one, but we can do it. And then the feature store, also that you have prepared the features for your models. You have a store, you can see who trained or prepared the data already, and then you can easily use them for machine learning. We have the model registry, MLflow, model versioning, which is there. You can pull out different models which others trained. Also now with LMMs, you can use external registry, Hugging Face, and so on to load your models. You can also put them in our own model registry. Then you have the tests, deployment, run machine learning. We also have MLflow, as on the other side. We have here deployment also of artifacts which belong to the models. We can add to MLflow. We have model compilation to make it smaller. We also have this one-click deployment, which needs that if you detect a model drift, for example, then automatically MLflow is triggered to train the model. And once the data scientist gets the alert, then he can check in MLflow if the new model is better, and then with one click, it will be automatically deployed to the rollout. There's still a human in the loop, but it's really, really fast. If you imagine without this pipeline, you would need to compile. Maybe he makes mistakes, deploys the wrong one manually, something breaks, or then quality would be low. So it's really a one-click deployment. And yeah, then we have model monitoring, for example, with Aporia. We have generic API developed by ourselves with a Flask fast API server in the background. User management is there. Data scientists can use it. Or it depends what is better. Sometimes we also use MLflow serve, or also Torch serve would be there to use, depending what you want to do. All right, and then the fifth layer is Gen AI layer. So we have a little bit changed the beginning, like the tech stack selection is now, I think, a big topic. Which stack should you take? Which vector database? I think how many vector databases are out there now? 14, 20, so it's really, really huge. Does anybody of you using a vector database? Anybody using? Okay, quite a lot. So who's using Qtrend? One little bit. Who's using Elasticsearch? Yeah, it's quite a lot. And the rest, what are you using? Milverse, maybe 8. Thanks. Anybody else? A different version? PG Vector? Postgres plugin, yeah. Behind there. ChromaDB for quick testing. Yeah, it's quite a variation. So I think it's a hot topic to select right now. The tech stack we have seen as a wide range. We need to choose the embedding models, LMM, which is there, development framework, evaluating length views, MLflow, all the tools, what are there to help us. And this is also good with this flexible framework because we don't know which way it will go. So we have now Qtrend, but we could replace it with some other tool. Data preparation, then the same data you have to select. You need the ground truth data. Also, there's MCP interface, which is now there. We're discussing from Anthropic that you have a standard interface where the agents can talk. Will be there that the data is accessible via agent and serving it. It's also on the other side from the deployment. The APIs you need. evaluation, memory integration, the history, let's say, of the chat, that remembers what the chat was responded before to react to it. Observability, it's very important. Prompt management, that we check what was inserted, does it answer the correct responses. Then the deployment, here we go also back to some classical DevOps architecture. We have classical front end and back end, front end just for the chat, back end to serve, and then we have the vector DB at the back end. It's really classical web development architecture design model. We have again the CI/CD like before, so we're reusing the other tools also for the Gen AI, which is there, and the MCP server. And then once it's run, we have front-end chatbots, we have guardrails to check that the answers are correct, and also the observability that your chat is working fine. All right, so let's jump as soon. Now we have 10 minutes with questions. Okay, so considerations. What we learned so far is to first get a good understanding of the current and future demands, then find a balance between both. So for example, you don't need a big Kafka cluster maybe if you only have 2 data sources to connect, or also now it's the new hype is MCP protocol to use for the agents, but do you need it really to check if it's ongoing or not? Find a balance that you're not too late, but also not, you don't need always the latest tool. Some simple tool might also do it. We had also some external tool was rolling out all machine learning management and serving and GPU and everything, but now it was open source. Now they switched to vendor. It was then also not bringing the business value. Now we using the classical Docker hosting like ECS cluster, or for example Kubernetes cluster, which is doing simple things, and still there very fancy things got squeezed out over the time. Also flexibility to replace the components. I have seen it there like over 15 years in data science, like at the beginning with Hadoop, and there was different tools, Datamir, and the tools come and go, so be flexible to replace them. Then there's a faster tool maybe, everybody's jumping on that way, so be flexible that you can change the pipeline. Fail fast early, also start with a small POC, not plan and concept, and then start developing really be smaller steps. So all this architecture, it's not that we sit there 2 years and then we design, or it was always small steps, increasing, removing components until we got there after years. Then look for generic solution, then specific use cases. It means like if you're in a company with more use cases, if somebody's coming to you and saying, oh, this is a cool use case, it's fine. But it's better if you have 2 or 3 use cases and then build for them a generic solution than just one moonshot project. Reserve time for data governance. It's really important. Otherwise, you have done a data dump. All your data is there. You don't have the overview. Also, what we did, especially at the beginning, then we had regular meetings every week to discuss about data governance, to improve it, to put the security, and so this is really important, and often it got lost. It's not so much fun, of course. And then also what we see is a lot of quick starts now, LMMs, here rack tutorial, setup. But if you don't focus on data quality, about user management, then you have this, your cool POC, it's good. But then often you underestimate how much it takes until you get in real production and get the productivity. And there we have also the slides, some numbers, which we presented at the beginning of the talk. So there's like 72% due to Gartner survey. They leading then to integration challenges and low ROI because they didn't check the ROI at the beginning, and then the costs also explode if you don't have this quality, if you just have a small POC. Pilot failures, also unrealistic expectations. Maybe you also don't see the complexity afterwards. You don't see that you need a user management, data privacy, and so on. And also very important, 56% is erosion of quality and trust. So if you don't provide the quality, you don't have a process, your chat is down, responses are not good, then people lose trust, and often there's no second chance to use your tool. And hidden costs also, which deliver. So what we have seen, it's just the tip of the iceberg to build a small rack demo, but then you have to build everything below, this automation, CI/CD pipeline to ensure the quality. And also the classical is in some companies you build a cool model, and then people leaving, nobody's touching it. But also management should know it's not just building a model. You also have to be there. You have to monitor. You have to improve. You have to train. It's not one shot. It's done. And like a website, maybe it's working some time, but also you need to manage and improve it. All right. There are some thoughts to also Gen AI. Then thanks for your attention. We have one remark. Please rate also this talk. I think it's out there. You're always reminded to do that. If you want to contact us, here are the contact details. I think we also send out the slides we provided to the organization team, and it will be sent then to you. All right, then thanks.
Thank you very much. Any questions? I think we have 5 minutes left.
Yes, we have some questions.
So how much did you develop yourself? Drop in some standard products,
Yeah, we have the standard included, but also maybe the question is for the online attendances. How much did we develop by ourselves? Normally we use like MLflow, all these tools, but it's also a huge team. So we have operations team around 5 to 10 people in Turkey who are doing this DevOps operations. We have data scientists all around the world as a team in Spain and Poland. We have this like innovation team around 10 people, also half in Spain, half in Germany to build up this and to get the connections and helping the data scientists to onboard to the cluster. So maybe it gives a rough estimation.
Yeah, and it's a mix. We always try to avoid developing something on our own. That's why we choose or do a lot of vendor management, picking the right modules and then writing essentially this glue code that is gluing these modules together. Like some data transformation layer in between so that these can work closely together if the format doesn't align. Or we create some boilerplate code as a Python library that data scientists that don't have this software developer background can have a quick start, so that we have also the smooth transition from POC into production. Yeah, so it's a mix between both, but maybe I don't know, 20% is maybe from our own code, maybe
From
even
the
less.
ratio, maybe less.
Yeah.
It's rough to us. This you cannot say because if you count the code lines from MLflow, probably
Yeah,
have less.
Sure. Yeah.
Yeah.
Yes, please. Yeah, it's mainly driven by the libraries that exist and also the open source tools, and therefore, of course, we converged to Python. We started out with essentially all back then, 7 years ago, all 3 major languages back then, which was MATLAB, R, and Python. But since a couple of years, nobody is talking about R any longer, and MATLAB is even more niche. Yes, the engineers that are working very close to the hardware, they use this often. I think it's called LabVIEW if you want to also simulate the physical processes and have a machine learning model running in this context. Then they use, for example, MATLAB. But it's very rare that anything else except Python is being
used. But it's also not limited because we have this container approach. We tell just the data scientist, here's a Docker container, put whatever you want. We just deploy it. You get maybe the port and then it's open. We provide them Python boilerplate codes. We don't go in specific languages, but they would have the possibility to put it in. Some we have also Java. Some applications, some are there, but then we just say, okay, here's the Docker container, put it in, we concentrate on deployment.
Yeah, and then you can even have a mix of languages, because as we also go in the direction of microservices, if you have a REST API, nobody cares what's behind that REST API, if it's which language is behind that REST API, and then the communication is just between these APIs. Yes, please.
The question is, how much time would it take to get a setup for this pipeline for the online participants?
Depends on the complexity of your use case, I would say. I think the first version, so it was yeah, we call it evolutionary architecture. So it evolved with each use case. But I think the first version was maybe after half a year or so, a couple of months. And we really started out as, I think, only the two of us. Then we got a third developer. So you can start really small, and after a couple of months, you already have a pipeline that has the automation, especially now that some of these tools are provided by providers by like AWS or MLflow,
Yes,
which also automate. But yeah.
Yeah, so it's also, you won't set up the complete pipeline at the beginning that we showed. Rather focus on business value to provide this early. Maybe some tool could be start first with MLflow, then you have the models trained, for example, you have the serving. Once you have this, then put something else on it, and then afterwards maybe CI/CD pipeline. So start iteratively. So don't set up everything at the beginning. Start with step by step. We don't have it here. Maybe it could be also nice to put this slide how to start. But yeah, start small and then put more tools to it.
And in parallel goes also the training, especially if you have the separation in your team that some people are more specialized on data science topics but don't have the developer background. They need some basic training that they can work seamlessly together with the engineers, so that they at least know the basics about best practice about code versioning, model versioning, and how to also create more or less clean code. Otherwise, if they put spaghetti code in, it would be really hard time for the engineers to make something reusable afterwards. This costs also some time. That's why we founded some in-house communities to forward and exchange the knowledge. Yes, please.
We asked to give a use case which we found most challenging at our work.
I have one if
Yeah,
you
fine.
don't want to start. So our most complex use case back in 2018 was APSA. It was called aspect-based sentiment analysis, where we scraped the internet about all customer reviews from all social media platforms in multiple languages to get these sentiments about our products, positive and negative as well, but also sometimes in one review you might have different aspects, like the fridge is very energy efficient, but the compressor is very loud. So we have two aspects, energy efficiency and loudness. One is positive, one is negative. And now you have to find the right model combination to separate these issues and have a good overview of all these aspects about the different products that can then be used in-house, for example, for the next generation, for planning the next generation of products, what needs to be improved, what aspects the customers are happy about, but also for maybe having more focused marketing campaigns. And this was the first time where we had to actually, I think the first time we used PyTorch, the first time we had to use the biggest machines and even multiple of them from AWS back then. So having also multi-node training, because back then I think it was the biggest model from BERT that just fit into the newest generation of GPUs, and we had to train 200 of them. So really for one iteration it took us, I think, 2 or 3 weeks with really using these very expensive machines from AWS, even a cluster of them, just to be able to train all these models. And it's around 50,000 reviews per day that are still coming in, and now it's deployed worldwide for, I think, about 50 languages. So this is really, this was quite a challenge, but it was a lot of fun. We learned a lot there.
Yeah, also we mentioned how big it's also the classical, because you have big data that people they set up pipelines and they have Power BI dashboard or something. In the beginning, they have maybe 1 month's data, everything is working fine in the dashboard. And then after 1 year, they come, oh, we cannot access anymore because the queries are so slow, because they didn't consider how it will be in the future, that they need to aggregate and to put the things. I think these are also challenging. Once they are with big data or also Kafka, they are also from perspective really tricky parts normally. Also Kafka, because there's different data incoming, they have different structures, different schemas. This is always annoying if they make updates or different connectors causing problems. And then if you have a lot of data. Yeah. Right. Behind was also a question. It was raising always the hand. So last.
Mm-hmm. I think that's something you might be able to answer better than me.
Yeah, we have different tools for the user feedback. So it's, I think, the BOM pipeline. So we get the data from the user if some errors are there, and we're handling it, preparing it, and then showing it to a different department. And they are, I think, the service desk, and then talking with the end user. So normally it's like a help desk or hotline who's talking then to the end user, if you mean like customer from BSH.
But hmm. Yeah, we built this into our generic rack pipeline. So what we recently built was, because we saw multiple use cases for rack infrastructure on the horizon, we built a generic infrastructure for that you can roll out with infrastructure as code. And there we already integrated also the thumbs up, thumbs down, because you want to make sure in a rack system that you are not suffering from hallucinations. So yeah, being sure that it's all backed by ground truth. And there we also had, I think it was a thumbs up, or at least it was planned to have a thumbs up and down together with a comment field, so that the user can also give some hints what is wrong, so that then the developers can essentially do the fine tuning and maybe improve the retriever component to get more appropriate text chunks back.
Okay. Then I would say we go to lunch, but if you have questions, you can still come to the front.
Yeah.
We're happy to answer further questions, but
Or just
I
write us
think
a
maybe
message.
everybody looking for the lunch.